Hi, everybody. So just before we get started, I thought we'd kind of have some fun. I thought it would be a little ridiculous to bring up a 3D printer and not give away something that we printed. In coordination with our university librarian, Donna Bourne-Tyson, who is watching from Halifax right now, the first person to get retweeted by her is winning our lovely Klein bottle that we printed up front. If you're not sure what that is, just go check it out on Wikipedia. It's kind of like a Mobius strip, but cooler. Today we want to talk about a 3D printing project that we took on at Dalhousie University over the summer. Now, thankfully, most of you, as I kept seeing huddled masses around the 3D printer, have probably actually now seen a 3D printer in action. But basically what a 3D printer is something that allows you to take a 3D digital model, you send it to a printer the same way as you would with a document, except instead of printing something out on paper, it uses plastic filament as a media. And it kind of goes around like a hot glue gun, and the base drops and it builds up an object like so, until you've got a physical representation of that 3D model that you had. We also got a 3D scanner. So 3D scanner works the other way around, and it's meant to bring physical objects into the digital world. So we got this one, which uses lasers to do range finding, to tell how far something is from it. It allows you to create a 3D replica of that object you were looking at. This picture doesn't show it, but it actually takes photographs as well, so you get the color texture on top of it as well. And then you can actually turn right back around and print a physical copy of what you had. So there was a great talk yesterday, and we learned all about the hype curve. So I was curious, and I went online to go find out where we lie on the hype curve. So we're not at the very top of the hype curve, but we're right next to it. So it's a really good thing we're doing this today, because by next year, none of you are going to care about this at all, according to this curve. But really, more to the point, we do think this does matter, but you might be asking yourself why. I know some of you have been asking me, how do I do this at my school, so you probably don't really care. But we've had 3D around a lot for a long time. In terms of visualization, it's now part of our culture all over the place. We don't even think twice when we see it. And in some cases, we can't even tell when we see it. We see it as people are designing objects, cars, toasters, you name it. We see it in flight simulators at the library in North Carolina that they're building. We saw the ship simulator. We see it in our movies, in our video games. We see it in medical imaging. We see it in mining gas exploration, and probably 1,000 other places that I can't even imagine. So we're doing all this stuff digitally, looking at computer screens. And what the 3D printing and scanning technology does is it starts to bridge that gap into the physical world. For us, as we were thinking about this project, 3D printers were really about starting to reduce some of the barriers for folks to bring ideas they had in their mind into physical reality. If you think of some of the models you may have seen out there, the tooling and the experience that would be required to cut these things out of wood, metal, whatever, would be significant. Whereas the ability to sort of fool around with Google SketchUp is a lot simpler to pick up, and most people are playing with it around already. The scanner is allowing us to start to preserve objects in a new way. We've all been preserving books for a long time now. Old books, books that we don't want to circulate, but we want to make available, so we scan them. Exact same thing here, where we've got physical objects in our collection that we want to capture, we want to preserve in their state, and in a lot of cases, we want to just put them out there for people to use in ways that they might otherwise not be. So the idea that came about came from Riel and Michael. They came to us in January. They were brand new MLIS students. And they came with a proposal that had 3 major thrusts. They wanted to bring 3D scanning, 3D printing, and a 3D collection to the Dalhousie Libraries. The technology already existed on campus. Our engineering people had a lovely high-end 3D printer. We had a visualization lab in computer science that had a very expensive 3D scanner. However, hardly anybody could use these things. They were generally closed off to the bulk of the student population. So this was about bringing this technology to everybody at Dal. We wanted to put it in a visible place, and we wanted to take the time to show it to people who had never used it, seen it, or even heard of it. So usually when we start to think about rolling out a new library service, we kind of go through a lot of steps. We go talk to a lot of people. We involve a lot of different areas. We didn't do that. There was one of those things that we thought we should really look at. When thinking about melting plastic right in the middle of our learning commons with a couple of hundred students floating around, we thought we should probably make sure we can do this reasonably safely. What comes out of the box, basically, when you buy a MakerBot, it comes with ABS plastic, and it's sort of pre-configured for that. If you melt ABS plastic, which is what your Lego was made of, anybody of you who melted your Lego realize that it produces a very unpleasant and potentially toxic set of fumes. So we couldn't do that in the Killam Library. As I said, high traffic place, old ventilation from the 60s, and no fume hoods readily available. So we had to figure out how we were going to handle that. The print heads heat up to 200 degrees Celsius. The equipment itself is somewhat fragile. We're using hobby gear. We're not using the professional industrial equipment. And we had questions about noise issues. Neither one of us 3 had actually seen one of these things ourselves, and so we didn't even know how loud it was. So we found these 2 great websites that provided gigantic lists of hackerspaces all over the planet, and we started sending out emails. Actually, more specifically, they started sending out emails. We were looking for equipment suggestions, alternatives to ABS. How were they coping with noise? Were they operating in a public space? Because a lot of hacker spaces are sort of private clubs. And did they have any health and safety data that we could actually just reuse?
So before actually rolling out the 3D printer to the general public, we had questions that needed better answers. And one of them was that there was no real 3D printing health and safety information out there. We had asked in our mass email campaign to hackerspaces if they had any concrete evidence on plastic and what it did when it melted. And we got a lot of suggestions to look at PLA plastic as an alternative. So we compiled our own information from material safety data sheets, and after that we consulted with Dalhousie University Health and Safety, and after that we decided that we were comfortable enough to go ahead and start troubleshooting the 3D printer and the 3D scanner in the IT space in the Killam Library. So this also gave us the chance to develop some proper usage manuals and maintenance manuals for ourselves and for staff, and future users. For our equipment choices, some of you have seen this just outside, we went with the MakerBot replicator for the 3D printer. And here are a few of the reasons why we chose it. First of all, it was affordable. It fell well within the pilot project's budget. Secondly, it was used in hackerspaces globally. We had heard that MakerBot was a popular choice, not just the MakerBot replicator, but its predecessors as well. There's also the open source software and hardware that attracted us to it. You've seen it, it looks, we were able to manipulate it to the way we wanted it to be. So that was a good point for us to go with the replicator. And also, the models are cheap to print. You've seen the models, and we wanted that to be a part of the whole service that we were going to offer. The next engine 3D scanner was the scanner we went with, because it was also cheaper than most 3D scanners on the market, and it's comparatively easy to use. It also produces decent results that we were able to work with, and it was also used on Mythbusters, if any of you have seen it, so that was another big selling point. So for testing and troubleshooting, we ran into some very interesting problems that Michael and I, along with Mark, solved during a practicum placement we did for our MLIS degree in the spring. First of all, the 3D scanner, we realized that there's a big learning curve. With anyone who's done 3D scanning will know that it's not like just taking a picture of something and there it is online. There's actually a lot of things to do physically and on your computer, such as playing with lighting, aligning it properly, and then once it's online, or on your computer I should say, you have to work with aligning the model because you're going to take several different pictures of it, and also fixing holes, the texture, things like that. We also had difficulty printing PLA plastic. PLA plastic isn't the ideal plastic for the MakerBot replicator. The MakerBot replicator is designed primarily to print ABS plastic. So we had to figure out a way to change the way our MakerBot worked so that it could print PLA plastic properly. So what we did was customize the heating temperatures. And the reason for that is because PLA plastic actually melts at a lower temperature than ABS plastic, about 20 to 30 degrees Celsius lower. And so we went into the software and were able to make those changes. We also had some issues with overhangs. And overhangs, to explain it simply, say I was printing an action figure, and the action figure had arms sticking out like this. Well, these arms aren't going to be on your build platform, which was the platform you saw on the MakerBot. So when it goes to lay down the plastic, when the extruder lays down the plastic here will droop and you're going to end up with very saggy arms. So there's a few solutions to avoiding those overhangs, and one of them would be maybe cutting the action figure in half and printing it flat and then gluing those two pieces together. That's one solution. But another one is MakerBot offers a feature that will let you have support structures. So instead of just putting these arms in midair, it will actually build a little web of plastic around. It's like a little plastic spider web, and it'll just be enough to hold the arms up, and then once you're done printing, you just kind of peel away that plastic fairly easily. And then something else we encountered in our troubleshooting was that we had a bit of trouble with scanned models and going to an actual printed object. So the complete cycle, I guess, going from a physical object like this, scanning it, working with it online, and then printing a replica of this object. We wanted really to go the whole way, and in the end, we did achieve that. So after all that time we spent in the IT lab, we decided to just go out and make it available to the public. The 3D printer went first, and soon after, we brought the scanner down to the help desk in the Learning Commons of the Killam Library. This is the first floor. It's high traffic, as Mark said, and it was very visible, but it's also behind the help desk. So it's because, as you've seen, it's the 3D printer is high temperature, so it kept it away from people with curious hands who wanted to put their hands in it. But the 3D scanner, we developed a system so it could be reserved through our room booking system. And so people could go in and book the 3D scanner, which was hooked up to a computer in our help desk area. And we made this a free service, so anyone could come in and book it. But we recommended at least an hour because of that learning curve I talked about. It takes a while to get used to the whole process. So especially for first-time users, at least an hour. For the 3D printing, we started up a service that students can send STL files, which is the 3D modeling files that we need to print with. They have to send it through 3dprint@dal.ca. So if you have your STL file, you submit it through that, and then the help desk staff internally book it in that same room booking system. And we charge $1 per hour, which would be approximately $4 for a fist-size model. So just to give you an idea of the approximate costs. And this was also a good time for help desk training. While we were there, while we were setting up this service, we worked with the help desk to make sure they were comfortable with this technology and were as educated as we are in what we were doing and understood the service. For promotion, we also did that while we were troubleshooting and while we were setting it up. We had a lunch and learn presentation, and this was a presentation we did for the Dal Library staff, but also for the general public. They were invited too. We did presentations for architecture and engineering, but we also did some wider campus promotion to non-traditional 3D printing and 3D scanning places like biology, physics, theater, computer science, and GIS. Some of you may have seen the topographical maps of Point Pleasant Park in Halifax that we had out there. We also had a few blog updates through our library blog and through our school's blog. And we had a Dal News article, a CBC radio interview, and we got a bit of public recognition from MakerBot on their blog when they had a blog post about libraries and 3D printing. But what we found was the most useful form of promotion were the quick 5-minute tours we gave to people who were just passing by or people who had heard about it that just wanted to learn more. And we spent a lot of time with people who were interested in learning more, and word of mouth spread fast.
All right, so when I received a file at 3dprint@dal.ca, the first thing I would do was run it through a program called NetFab. And what this program did was analyze the model for any errors, and in most cases, fix these. The most common error we saw was what is called self-intersecting vertices. And what this means is someone, say, was making an ice cream cone in a 3D modeling program. They would take a cone and a circle and kind of wedge them together, and you get something that looks like an ice cream cone. But the problem there is when you try to 3D print that model, it's actually going to see the circle running through the cone. And this leads to all kinds of problems. So NetFab was a way of correcting that before we encountered those problems in our printer. We then use another freeware program called MeshLab, which would, it's basically image compression, which would simplify these programs and make them much easier to print. From there, we would use the software replicator G to generate what's called the G code, or the coordinates that the machine needs to print. And then from here, we'd have a time estimate that we could give to students back for printing. So we launched our service right at the time of the Dal News and the CBC News article, so we had a lot of publicity going into this. We had about 15, 20 submissions right off, and we had the printer booked up for the first 3 weeks solid. Since then, we got about 2 submissions a day, so keeping up was no real problem. Overall, we had about a 50-50 mix of academic and recreational models. We really missed our target audience due to our timing. We launched during the summer. We were looking to bring these kind of technologies outside of engineering and architecture where they've traditionally been. But the problem was during the summer, mostly engineering and architecture students were on campus. Everyone else was away on vacation. So they were definitely our main users. We also found with the 3D scanner, in a lot of cases, people were looking more for a full service. While some students were interested in coming in and learning the technology, and I would make time to sit with them for 2 or 3 hours and instruct them how to do this. A lot of other people were just looking for a full service. And 2 examples of this are the Thomas McCulloch Museum and the Museum of Natural History, both Nova Scotian museums. So the Thomas McCulloch Museum was a museum on campus in Dalhousie, who had a collection of birds. Thomas McCulloch's a famous Nova Scotian bird collector. So they approached me to 3D scan a number of birds from this collection. So that's something I worked on over summer, as well as we took advantage of their large collection to 3D scan some anatomy models, as well as various bones from animals around the area and things like that. I also worked at Nova Scotia Museum of Natural History this summer to 3D scan Titanic relics. Like we had a silver sugar bowl from the Titanic shipwreck, a bunch of Mi'kmaq heritage objects such as straw baskets and dolls. I 3D scanned some broken ship metal from the Halifax explosion, and also a number of local archaeological finds such as pro-war bowls. We had much less people use the 3D scanner than use the 3D printer, and they were predominantly from the Faculty of Architecture. The reason for this was we had 2 architecture professors really take a strong interest in what we were doing, the 3D scanner especially. And so they made this kind of part of their coursework over the summer and would send their students down to work with us. And so they were very interested in that fact. But no professors used the 3D scanner over the summer, actually. It was all students. 3D printers, we had a lot more users take advantage of. We had about 100 users total over the summer. I'd say about 30% of these were repeat users. Almost all were students. Very few faculty members came and checked it out. Most students were from engineering, architecture, and computer science, but again, these are the students most heavily represented during the summer when we launched the service. We had the 3D printer open to the general public as well, but we didn't really promote in this area, and so not that many people took advantage of it outside of the Dalhousie campus. In our experience, most people who were using it had heard of 3D printing, but had never really seen it before. So some examples of projects. With architecture, who, as I said, were mostly interested in the 3D scanning. One example you can see up here is kind of, I call them like clay building thingies. They had about 40 of those of just different sizes and dimensions. And so I 3D scanned those, and they take them into Rhino and kind of put them together in different ways and see if they could get different building models out of it. They'd also, to kind of save themselves time, bring in different paper buildings. And I'd 3D scan those and put them into Rhino, and it was kind of a faster way for them to do 3D building models. And also for a side project, I 3D scanned a screwdriver to help them build a CNC machine that they're working on in the basement. A 3D scanner, or engineers didn't use our 3D scanner at all, which made sense because they had a much higher end 3D scanner in their old campus. A few students gave us personal CAD models, like one student had designed anchor earrings that she just wanted to kind of print off and see what it was capable of. We had a lot of submissions for multiple prints of a single model for thesis presentations. So a engineering student would have a really expensive prototype part that would say cost them $24. And they'd be doing their thesis presentation, so they'd be looking for 5 more copies to show the people kind of grading them and making the decision. So they'd come to us to print it out much cheaper for, say, $4. And that way save a lot of money for something they wouldn't need so many copies of in the long run. And we also saw a lot of use by engineers for pre-rapid prototyping prototypes. So what I mean here is that before they would take their actual part to be 3D printed on a higher-end 3D printer, they'd come to us first to see exactly what it would measure and if it fit purposely or correctly, and then make the required adjustments before they would get their higher-end product printed for the extra expense. We had a few chemistry and biology students give us projects as well. The one you see up on screen was a 3D print for cellular structure. There's actually 5 of these pieces that would clip together that would then be used as kind of a mold to form these cellular pieces. Also, a PhD student from biology had us printing out a lot of molecular structures, so like nucleuses and cellular structures like that. So overall, it was a lot of visualization of research work and thesis presentation kind of thing. A few non-academic projects came through as well. A lot of people involved in the Halifax Comic Convention really took an interest in it, so they were on talking to us most of the summer. We had a lot of experimentation with models on Thingiverse.com. This is a website run by MakerBot, whose 3D printer we're using, and this is a website where users can submit 3D models that can be freely downloaded and used by other users, kind of an open source Creative Commons community, so we had a lot of submissions for models from there. A lot of students were giving us Google SketchUp models. This is kind of the Microsoft Paint of 3D design. So a lot of people would just design their own things quick. It's kind of like nerd swag, I think they call it. So it'd be like rings and bracelets and things like that they design quickly and print off. We had a few replacement parts for various broken clips and things like that. And some computer science students had us print off Arduino cases for them. So the thing that really went well for me anyways over the summer was that the service worked as intended and I kept everything running the entire summer. So the 3D printer never broke down, the 3D scanner never broke down, everything went smoothly. We never had to cancel any prints, we never had to turn anyone down, so there's no like catastrophic events like that. The price point was really well received. The models that we were getting in, I think pretty much all of them fell under $5. So students were really happy with this price and definitely was the reason they came back to us. We also heard a lot about the accessibility of the technology. The fact that we had it in the library completely open, people could walk in and see it. Like, hey, I heard about 3D printing, is that one right there? And we give them a quick introduction and show them around, where before in a lab setting, they maybe heard about it, but wouldn't feel comfortable walking in and taking a look. Project promotion was very successful, and just overall, there's with so much curiosity in this technology, we found we were very successful in doing more for people to get a first-hand experience with it.
So, where do we go from here? We definitely have to keep working on educating students and faculty on printing. So there's multiple levels of that. First off, we've got folks who just really don't know anything about this stuff, are interested by it, are fascinated by it, and want to get into it. And so we've got to help get those people up to speed. But even with people who know what they're doing, have used 3D printers before, because of the grade of 3D printer we're using, there come additional limitations. Those overhangs that Riel was mentioning aren't an issue if you're using a powder-based 3D printer, some of the higher-end stuff. We need more information on how to scan images properly. We have a sort of step-by-step guide, but it was a little dicey. People got through it, but we think we can do better. We're going to be developing some video tutorials at some point soon to help people get through it. We want to try and tie this into the curriculum a little bit more. Not in any sort of forceful way, but very much in the way that what happened with the architecture faculty members who just saw it and said, you know what, this is great. This is exactly what my students need. And we want to try to make more of those connections as we go forward. We're going to be promoting the system as well, because we have no doubt that there are all sorts of students all over the place that this will not directly tie into their curriculum, however, can have a very profound impact on their learning. We're going to be troubleshooting, I guarantee you. The configurability cuts both ways. It's great, we can change anything. It's terrible because we can change anything. We're going to be looking at maintenance over time. It worked great for the we're into 6 months now that we've been operating it, but what does it mean to operate one of these things for 2 years? We don't know quite yet. You may have noticed we didn't really talk about the 3D repository too much. We need to start making some headway on this front. We put a lot of our effort into the actual services for people to use, and this one sort of fell back a little bit. We want to really integrate it into the process, so when somebody comes with institutionally relevant models that they want to print or institutionally relevant objects that they want to scan, we want to make it very simple for that to funnel off into the institutional repository. We're going to be working on a metadata scheme while at the end of the day it is just stuff, and a lot of the same stuff applies to describe it. There are a few special bits and pieces with 3D models that we want to capture. We're going to keep looking at digitizing some of our stuff in our own archives and special collections. Copyright and open access, it's going to be fun to watch. Anybody who's been paying attention to this stuff noticed a company just patented some DRM for 3D printers. Who knows what role that will play, but I suspect it's going to roll out pretty much exactly the same as we saw it roll out with music and then with movies, and now we're going to see it with 3D objects. The same kinds of companies are going to come forward with the same kinds of challenges, and we're going to get the same kind of pushback from creative communities. For now, what we're doing is we're essentially leveraging our photocopying and printing policies and just applying it to this. So we're going to continue the pilot. As mentioned, we sort of missed our target audience over the summer, which was okay. We got a great chance to debug a lot of little issues, so we feel much better prepared to help people who haven't done this before get started. We're considering deploying a second printer down at the Sexton Library, which is our engineering library, because we did have engineering and architecture, because we had a significant client base coming from there. And they're actually physically far from the Killam, a couple of kilometers at least. We are thinking about higher-end equipment. I know some of you have asked me about that. It's not quite the no-brainer you'd think. There's a little bit more people time involved in some of the higher-end equipment in terms of what we've seen demonstrated to us as compared to what our experience has been with ours. The results are fantastic. The models are truly great coming out of the high-end stuff. It is uncomparable to what we've got, but we don't really have the people time to throw at it. However, we did get a call from the head of the Dalhousie Print Center, who attended one of our presentations over the summer, and said that she really would like to talk. She's very interested in working with us. We're looking at, and we've had a few requests for flat-out instructional sessions, and I think that's generally been coming more from people who aren't familiar with this and really want a sort of guided, step-by-step, help me through creating a model, and oh, I'm stuck, can you come give me a hand? So we're gonna try and put those together. The question of hackerspaces has come up. 3D printers are very common in hackerspaces. However, when you kind of think of a traditional hackerspace, you usually see CNC machines, welders, laser cutters, all kinds of really noisy, loud, stinky, dangerous machines, which don't normally lend themselves well to academic libraries. But 3D printer and then our lovely Arduino project, which I presented earlier, you take those two things and you start to create a specific subsection of a hackerspace that could actually fit quite well within an academic library if there's groups that are interested in working with that. We had a great discussion about it at Code for Lib East. Woohoo! Everybody should go next year. It was fun. Ultimately, though, users are going to drive the service. We did this, toss it against the wall, see if it sticks, but over time, we're not going to continue to push something that nobody wants to use. But I think you've seen that we definitely reached people, even at a time when there weren't a ton of students on campus. We had a steady flow of people who were really interested in using this and doing this. So we have basically found that there is definitely a niche to fill with inexpensive 3D printing and scanning services at an academic library, at least for us. With our experience, we found that IT people do seem to be a little bit necessary to the process, but I'm not thoroughly convinced that that's the case. And I'd actually really like to hear from anybody who's gone through this experience without their IT staff. A lot of this stuff really just requires interest, tenacity, and a willingness to break things and fix them. So that's not strictly within the IT realm. However, employee training will be necessary. Folks do need to have time to work with this, figure out how this works, because there are little oddities to it because we're working in a hobby grade market here. We definitely have a need for education at all levels, as mentioned before. But more importantly at this point, and I think it's been fantastic to talk to everybody so far over the last couple of days. I've had a ton of questions. And a lot of you are actually really interested in doing this at your own institution. We want to see you do it. We really do. We feel like we've engaged our students in a way that we hadn't engaged them before. We got them to work with us, learning in ways that they may not have done before with us. And I just think that's fantastic. And I would love to see everybody else do it, and I would love to see everybody else do it better than we did it so we can just blatantly copy your wonderful ideas and bring it to Dalhousie. Any questions? Do we have a winner? Anybody? What? She retweeted you?
She retweeted me.
Hey,
Oh, there are questions. Yeah.
question. The plastic, that's great. You guys have health and safety going for it, but I have an important question. Is it microwave safe?
We don't know.
No, it's not. We tried it. No, it's not microwave safe.
Okay, we do know.
So my cereal bowl will melt if I heat it there.
Probably. Since it melts in the print heads, it'll probably melt in the microwave.
Other questions? Oh.
I saw that you had a lot of engagement with students, but the engagement level with faculty was quite low. How would you go about encouraging that sort of use, having the technology used by faculty? Having it as a way of teaching tools, that kind of thing, or do you have some ideas how you could do that?
I don't myself. I know Michael was working with a couple of presentations to some faculty members. Mike, did you have anything?
Yeah, I think the problem with 3D printing right now, it's like Mark showed the hype chart, it's a #1 hype technology. And so we're like a library coming at you with this new technology that's got all this hype around it, bringing it to professors, and I think they just have that cynicism about it. They're like, oh great, why am I gonna waste my time learning this whole new thing for my job, and it's gonna go away in a year. So I think a big part of it is gonna be more presentations and promoting, and actually showing them what it can do for them, and making it, I guess, relevant to their own needs. And just, yeah, proving it to them that it is useful, and it's not just a hype thing that's a waste of their time.
And I think we got lucky with having those 2 faculty members who got interested really early, and I think using examples of their peers is going to go a long way as well.
You're charging $1 an hour for these objects. How
Yep.
does that relate to the cost of the actual reels? Is this a cost recovery or a loss?
We are cost recovering on the materials only. We're not cost recovering on the machine for that one. So that covers the cost of the plastic.
Thanks.
Any other questions? No? Excellent. Well, thanks very much, guys.